What's up, junkies? Today, the C word is compass. Because remember, if you smoke that meth and not that meth, you understand a whole lot more shit. And you can keep your brain cells and your teeth. So, we left off on coordinate systems on our little tour of mathematics, and I'm heading towards the equation of life. And today I'm going to talk about transformations. A transformation is taking this thing to that thing. How did, the juice out my nuts and my wife's egg become a baby? How did those nuts get crushed and now I got deez nuts? And the truth is, this shit's pretty hard to understand, big time. And what I mean by that is it's hard to represent mathematically in a model how a baby is made. But our brain picks that shit up pretty easy. We want to know how it happened and why it happened. Well, how it happened was juice, egg, in an oven, bacon for 9 months, becomes a baby. Why did it happen? Well, probably because we were horny. Our brains can understand that. Our brains understand the baby making process, the nut crushing process, but the shit's hard to write down and model with a mathematical equation because, unfortunately, most of everything in the universe, which includes life, is nonlinear. And while our brain processes these acts of nonlinearity, we don't like it. And we don't like it because we're emotional and we don't like shit to be nonlinear. It's even hard to understand what that shit means. So here comes one of the secrets that I'm going to tell you that when I was learning mathematics, I wish somebody would have told me, because it took me a long time to finally figure out what the difference is between linear and nonlinear. And then if it is nonlinear, why is it nonlinear? So nonlinearity happens when things compete against each other. If you have a hot girl in the bar full of sausages and they're all competing against each other for that girl, that's a very nonlinear process. In other words, you can't predict who's going to go home with her. If you listen to your two favorite songs at the same time, it sounds like shit. That's because they're competing together for your ear, and that is a nonlinear process. And that shit's just hard to understand. And most of the universe is like that. So this whole idea of nonlinearity brings me to the worst kept secret in the history of the world. And that secret is that life is nonlinear. And your math teachers have been yelling it and screaming it, their little secret, to all of you, and you just aren't listening. And you generally go through a process to stop listening to mathematics. So your loss of interest in mathematics starts like this. You're in school, you say, that's a number line. And this is 1, and this is 2, and this is 3, and this is -1, and it goes on. And the teacher tells you that all the numbers are on this line. We got the real number line, and it's one-dimensional because it goes in one direction, left and right. And then they say, hey, 2 plus 1 equals 3. So you have 2 plus 1 more equals 3. Like, man, this shit's easy. And then they get a little more complicated and they say 2 times negative 1 equals negative 2. And 2 times negative 1 equals negative 1 plus negative 1 equals negative 2. So you go negative 1 times 2 puts you here. And you say, man, this shit's easy. So now you're all fucking smart and shit because you understood how to add and multiply some numbers and some other things on that one-dimensional real number line. So your teachers say, hey man, let's up the ante. Let's see what's going on here. So they give you your same number line. And they're going to throw into the mix this one. It's also another real number line. If you remember from my last video, you know that if I multiply R1 and R1, and this one is the x-axis and this one is the y-axis, I'm going to get R1 plus 1, which is going to give me R2, and this is considered a two-dimensional plane. And in this plane, I can draw a line. Good, close enough. And they're going to say, all right, for every one you go over this direction, you're going to go up 2 in this direction. So if I go over another one right here, I'm going to go up another 2. This line's a little off, but it would be here. And this line is going to be y equals 2x. So no matter what x I put in, I'm just going to multiply that shit by 2, and I'm going to get a point on that line. And you're thinking, man, this is really easy shit. So you said, throw this at him. Boom. And they tell you that this is a nonlinear line, a nonlinear graph. And you can find the roots of this line, which is where they cross this x-axis, with this formula. And it's going to come from an equation, this particular one, that looks like this. Y equals negative ax squared plus bx plus c. And at this point, all your classmates are going, that's it. We don't need this shit in life. We don't need this complicated crap in the future. And you dip out. Mentally and everything else. When you decide to dip out of math, when you start getting to something that is really this simple, because you think it's complicated, you have then abandoned the worst kept secret in life by math teachers and scientists that say life is nonlinear. And you've decided to 86 the idea of pursuing it even further, even though everything you do is nonlinear. Everything you do is nonlinear. You're not getting in any linear fights. I punch you, you punch me, I punch you, you punch me until one of us wins. No, that shit's going to be non-linear. We're going to start throwing hands and we're going to start rolling around on the ground, and you're not going to be able to predict what's going to happen. But you've decided that you would rather stick with that easier linear shit. So you dip out. So for those of you that decide to continue on and not dip out immediately and decide to learn some other shit about nonlinearity, R1 times R1 times R1 is going to be equal to R1 plus 1 equals R3, and this is going to be equal to 3-dimensional space, and it kind of looks like this. This is the z-axis, and it's a real number line. This is, of course, the y-axis, and it's a real number line, and this is the x-axis, and it's a real number line. Now in this space, you're going to have, say, a shape, like so. So you have these x and y values down here in this shaded region of the plane, and you have this surface up here on the z-axis. So you can imagine that you're taking some x and y value, and you're applying it to another one of these functions, and it gives you a point up here on this surface. And This shit, while your brain is understanding, hey, that looks like a shed in the backyard sitting on the ground, which it is, you might be asked to find an equation for that surface, for that shed. You might be asked to find the volume of the shed, or even partial volumes of it. And this is when you get into some sort of second level and third level calculus stuff. And then, your professors might say, well, then you might have something like this. Boy, looks like a tornado. And you have some point here that is on this line, and it started here, and you have some function that predicts where it's at any given moment. And then you could even do some crazy shit and be like, we have some point, it's sort of going all over the place, and then it circles in and dies right here. That would be called a fixed point. And this curve would be very complicated. But I'm here to tell you that this is still some pretty easy fucking shit compared to the universe and all the crap going on in it. Because most things in the universe operate like this. R to the 1 times R to the 1 times on. R to the 1 equals R to the 1 plus 1 n. And there you go, some mathematical terminology for something that is Rn, which means it can be, we did R1 and R2 and R3. Now we can do R4, R100, R1000, and all that shit's extremely nonlinear. And in the universe, there is some linear things peppered in there, and there ain't a damn thing we can do about it. So all of you that bailed out of the quadratic equation and was like, I don't need to understand this shit, y'all just bailed out on what your brain does naturally. You see, the thing about nonlinearity is you're looking for things that are the same. When you do a transformation in a nonlinear environment, something is probably going to stay the same. How about, what if when the World Trade Centers collapsed, I think they found some firefighters were the last people they found alive in there, and they were in this stairwell that when the building collapsed, the stairwell, that little portion of it, didn't collapse and get destroyed. It stayed the same as it was before the transformation. This idea of a transformation, of finding the points that stay the same, or finding the points that things are attracted to, or finding the points that things go away from really, really fast, I think that that's important. And let's think about in life what we do when we think about what stays the same. When you go to work and you're working with a bunch of people, what stays the same that day? That's probably important for everybody there. So this idea of, fixed points that things go away from and things collect to, or what stays the same, is a very mathematical concept, and you do it every fucking day. But yet you don't want to know how to do the math underneath it. Well, that's what I'm hoping to change.